Next students, I am Dr. Srinivasulu, working as a professor in Siddhartha Institute of Science and Technology in the physics department. Students, today we are going to discuss about the crystallography. In crystallography, we are going to handle how the crystal structure is studied, what are the differences between crystalline material and amorphous material, and also we cover the basic definitions of unit cell and definitions of simple cubic crystal structure, body-centered cubic crystal structure, and face-centered cubic crystal structure. Students, through the PPT, we are going to cover all these introduction points of crystallography. Wait 1 minute. Students, see this here. Today we are going to present a PPT on crystallography. In this crystallography, we are going to cover what is crystallography, what we have studied in crystallography, what is crystal structure, crystalline solid and amorphous solids, definitions of unit cell and simple cubic crystal structure, body-centered cubic crystal structure, face-centered cubic crystal structure. Students, here in the crystallography, we studied about the geometry and the structural properties of crystalline substances. The branch we studied about the geometry and structural properties of crystalline material is known crystallography. Here, who are studied about the crystal structure are known crystallographer. So here, the branch which is studied about the structural properties of crystalline substances is known crystallography. Who are studied about the crystallography are called crystallographer. So here, crystal structure. In the crystal structure, the periodic arrangement of atoms or molecules or ions in crystalline substances over along a atomic distance is known as crystal structure. That means crystal is the composition of atoms, molecules, ions. So how these constants in the crystal arranged is called crystal structure. Simply crystal structure defined as combination of space lattice and basis. Students, generally these crystalline substances are classified into two broad categories. That is, one is crystalline amorphous. Here solids are classified into two broad categories. One is crystalline, another one is amorphous. Again, crystalline materials are classified into single crystalline, polycrystalline. Students, here see these differences between crystalline material and amorphous material. Here, in this diagram, in crystalline materials, atoms are arranged regularly. But here, in amorphous material, atoms are arranged randomly. All crystalline materials have sharp melting point. That means at certain melting point, these are converted into solid into liquid. But amorphous material does not have sharp melting point. Where we give the temperature, there only we observe some deformations in the structure. Its cooling curve is brief. That means if we place any metallic crystal in the hot metallic crystal in the liquid, suddenly it loses its entire temperature. That's why we said its cooling curve is brief. It has slow cooling curve. If you place the hot plastic material in the water, it loses its temperature slowly. That's why we said it have slow cooling curve. Amorphous material have slow cooling curve. Crystalline materials have sharp cooling curve or cooling curve is break. Here, these are anisotropic type. These are amorphous materials are isotropic type. Anisotropic means if all the properties of the material in all directions is same, then we said that is anisotropic. So all metals and silicon, germanium have anisotropic behavior. Here plastic material, glass, diamond and rubber have the isotropic behavior. So these are the some comparisons and differences between crystalline material and amorphous. Crystalline materials are also called metallic crystals. Amorphous materials are also called non-metallic crystals. Students, every crystalline material is have large number of unit cells. Suppose if you take the NaCl crystal structure, it have the large number of NaCl cubes. That's why we said the smallest portion of crystal lattice which have repeated in different directions will generate the entire lattice. That means the smallest measurable portion in the entire crystal structure is known unit cell. So here see this unit cell diagram. In this entire structure, large number of unit cells are there. This is the first unit cell, second, third, fourth, fifth, sixth, seven, eight. In one simple cubic structure, 8 unit cells are there. So here unit cell means, how you define unit cell? The smallest measurable portion in a entire crystal structure is known unit cell. So based on the atoms are arranged in the unit cell of any crystal structure, crystals are classified into 3 main categories. That is simple cubic crystal structure, SCC, body-centered cubic crystal structure, BCC, and face-centered cubic crystal structure, FCC. Here these are the diagrams of simple cubic crystal. Here in simple cubic crystal, every unit cell have atoms at its corners only. Every unit cell have atoms at its corners only. That is the simple. If any unit cell have atoms at its corners only, then that structure is now simple cubic crystal structure. Suppose if any unit cell have one extra atom at the center of the body along the corner atoms, then that is called body-centered cubic crystal. So this is the body-centered cubic crystal diagram. Face-centered means if any unit cell consisting of centered atoms at its all faces along the atoms in corners of unit cell, then that structure is known face-centered cubic crystal structure. Students, so this information is there in modern engineering physics. It is the one textbook who author is Dr. K. Vijay Kumar and Dr. S. Chandralingam. And also you refer for this crystal structure engineering physics by Dr. K. Tyagarajan, engineering physics by Dr. T. Palaniswamy. For additional information, you go through the NPTEL videos on crystallography and crystal structures. Thank you. With this, I'm complete this session. Thank you, students.